All right, boys and girls, let's get into another skill. Today's skill is on non-right triangle trigonometry. Really, a skill that you learn in pre-calculus that shows up on the ACT all the time. Really, it shows up on the harder questions of the ACT, really the last 10 or 15 questions on the ACT. Let's take a look at how they work. Well, there's two or three different cases. Let me show you all of them. The first one is called law of sines, and the formula for law of sines is given to us right here in pink. It's sine of A over A equals sine of B over B. And the way that this works is that you have a proportion of angles to sides. Really, if I draw you a nice triangle like this perhaps, and I told you that this was, 34 degrees, this is 10, and then this was, let's say, 29 degrees. What you can do here is you can use a set of pairs. That's how I always teach this. You can use a set of pairs to kind of suggest what's going on. Really, for me, I understand that there's a pair here to create a proportion with, and then there's a pair here to create a proportion with. In which case, how would this work? Well, you would have something that looks like this. You have sine of 34 over 10 equals sine of 29 over question mark. At which point, if you have fractions set across an equal sign, what can you always do? You can cross multiply. I end up with sine 34 times question mark equals 10 sine 29. And at the end of the day, how do I get rid of that question mark? Really, how do I get this thing alone? Well, I should divide both sides by sine 34. And what's nice about the ACT is typically they don't even make you simplify this. You just have to dig around the answer choices and pick whichever one has that answer, or really that setup. Let's try applying this skill to two different questions. Really, we'll start off with an easy one, and then we'll go to a hard one. If you take a look at number 45, I'll zoom in for us a little bit. Take a look. It says law of sines in the notes, and it shows us a nice triangle. The first thing to recognize here is there a set of pairs? It's telling us to use law of sines. There should be a set of pairs. Well, there's this pair here, but if I want this question marked side, I probably need this angle up there. So that's a quick little lesson to learn. Really, if I need that angle, maybe there's a way to find that angle. And of course there is. 180 minus 34 minus 41, really subtracting this angle and this angle away would give you this big angle. Or just take a look at the answer choice. It's probably 105. Thus, this angle up here probably is 105 degrees, and at that point, I'm going to ask that question again. Do I have a set of pairs? Can I set up a proportion? Yes, I can. I have sine of 34 over 25 equals sine of 105 over question mark. From there, what did we say? We cross multiply, so we have 25 sine 105 equals question mark sine 34. At which point, I'm going to divide both sides by sine 34 and be done with it. That, my friends, is our final answer. It's B. They're not even making us simplify this or do the calculation. That's so nice. Let's come over here and try another one, a harder one perhaps. This is a number 59 from a 2021 test just last year. How does this work? Well, without reading too much, it says the string. I want this side, the string. In which case, if I want that side, of course I have this kind of pair here, but I don't have another pair. I don't know this side, and I don't even know this angle to create a proportion there. But in fact, you can find it or unlock it. If you do the math here, again, similar to the previous question, 180 minus 45 minus 75, of course, you get 60. That angle up there was 60. In that case, you can create a proportion. You do have a set of pairs. There's a pair right there. I understand that this is going to be sine of 60 over 240 equals sine of 45 over question mark. At which point, we're going to make a nice cross multiplication, and we have 240 sine 45 equals question mark sine 60. Now, divide out both sides, sine 60. Unfortunately, we actually have to do the math on this question. And now, when you do that, you should find that the answer is B. Take a second to make sure that you can do this one. This one, like I said, is a little bit tougher. I'll zoom out so you can see both questions. That was law of sine. If you have any questions, obviously go back and rewatch or leave a comment down below asking your question. Now down here, I want to come to law of cosines. As you can see, this is law of sine's ugly cousin. This one is a lot worse. The idea behind this one is, like I said earlier, pairs, well, this is when you don't have a set of pairs. So this is called no pairs. And how do I set this up, or how does this work? Well, if I have a nice triangle like this and I say that this is 140 degrees, and this is 10, and this is 11. How would this work? What would this even do? How could I set this up? Well, let me first ask you this question. Is there a set of pairs? Is there a pair here? No. Is there a pair here? No. Is there a pair here? No. In that case, this is when you don't have a set of pairs. You're going to use law of cosine. And how does law of cosine work? Well, this angle, the big thing to know here is that this angle and this side always face each other. I'll say that one more time. This angle and this side always face each other. So if I have this angle, cosine of that angle, which side would this unlock? It would unlock this side. I'll say that one more time. This is cosine of the angle. Cosine of the angle will always unlock the opposing side, the side that it's facing. So how could we set this one up just so we have a decent example to start from? This one would be c squared equals a squared plus b squared minus 2ab cosine of 140. I'll zoom out a second so you can see the whole formula matched up with that. And at the end of the day, you're going to have to do some calculations, and really the final step would be, of course, getting rid of this square. How do you get rid of a square? You're just going to square root the other side. Like I said for law of sine, when doing law of cosine on the ACT, you actually don't have to do many of the calculations. They just set it up for you. You just have to determine which one is correct. Let's take a look at two hard questions. Let's come down here and try this one first. Pause the video here if you want, and we're a little bit lucky here because they've actually given us the formulas that we need. Sometimes they don't, so you do have to have them memorized. But in this case, let me ask you a question. Do we have a set of pairs? Is that a pair? No. Is that a pair? No. Is that a pair? No. In which case, we're not using law of sine, we're using law of cosine. Again, c squared equals a squared plus b squared minus 2ab cosine c. At which point, yeah, if we're trying to unlock side BC, it's going to be opposite of angle 40. We have question mark squared equals 12 squared plus 18 squared minus 2ab cosine of 40. And like I said, how do we get rid of that square at the very end? What's the opposite of squaring? Yeah, we're going to square root this, and we're done. Essentially, the answer is E. And this question is actually even easier than it seems to be, because look at A. A is right triangle trig. B is right triangle trig, SOHCAHTOA. C is Pythagorean theorem. D is Pythagorean theorem. Just by process of elimination, we could have came to the conclusion that the answer is just E, straight up. Let's try our hardest question of the day over here for this one. This is a number 60 from another test. Take a second to read if you want. It says the sides of an acute triangle measure 14, 18, and 20. Which of the following setups gives you the setup of the smallest angle? Well, let's draw something here just to help us visualize it. We know that the setup is 14, 18, and then 20. At which point, what did we say? We said the smallest angle of the triangle. Oh, well, the smallest angle will oppose the smallest side. In that case, I'm looking over here. Now, how would I set this up? Of course, it's not law of sines. Law of sines requires a set of pairs. Is there a pair here? Is there a pair here? Is there a pair here? No, you have no angles to create that proportion with. In that case, it is indeed law of cosine. How do we set this up? Well, what did I stress earlier? I stressed the idea that, if you want the smallest angle, that's going to be facing the smallest side. Look, this angle must face this side. So if I want the smallest angle, aren't I going to choose J opposing the 14? Whereas 20 squared, really K, would be opposing the largest angle. Doesn't make much sense. In that case, you're right, the answer is J. So those are just 2 examples of law of cosine. Of course, there are a million more. If you want me to do some of the harder ones, please comment and chime off in the comments, and I will make sure to do some of the harder ones. I'll zoom out here so you can see all of them, and I am going to be uploading a video of me doing area of a non-right triangle. Again, another skill that does show up on the ACT, so if you want to see that, let me know. Thanks for working, guys, and I will see you soon.